All right. Good afternoon once again. Thank you for joining us today for our live session. This is for first, second grade to about 7th grade. If this is your first time, welcome. Thank you for joining us. If you've been attending, you're also welcome. We appreciate your support. Also, feel free to drop as many questions as you have. If you have any questions that you're working through in school that is not clear right now, please let us know. We're glad to help you with that. And if there are any areas that you may want some additional help with, let us know. If there's any way we're going through our problems that is not clear to you, also indicate so that we can go through that with you as well. And so we're going to, like I said, we're going to go through our first, second grade to about 7th grade today. And feel free to answer any question. You don't have to be a second grader to answer a second grade question. Anybody's free to answer the questions. We will make sure we're going to actually have our puzzle in the middle of the session, and at the end of the session we're going to try to switch things up a bit. And so looking forward to enjoying the hour with you. And so let's get started. Those who are new, thank you for joining. The way we're going to work through our session is I'm going to put up some questions, and then I'll give you a chance to try to answer the questions. And after a few moments, I'll show you the simplest way to do it. And if you have a simpler way, you can also let me know that you have a simpler way, and we can look at it together. So I'm looking forward to the time. I think it's going to be fun. And so let's get going. All right, Simi, how are you? I hope school is coming along well. You're enjoying school. Limunga, good afternoon. Emmanuel, good afternoon. Good to have you on board. So we have several questions today, and the topics, I try to change the topics here and there. And so today we have word problems that have to do with place value and estimating differences. So I'm going to give you a few moments to attempt this question before I go ahead and show you what to do. Shewano, good afternoon. How are you? How is school? All right, so we have Laurie has 659 pieces of Skittles. She gave away 439 to her class for answering questions correctly. Round each of these numbers to the nearest 10 and estimate the number of Skittles left over. We're going to round each of these to the nearest 10, and then we're going to estimate the number of Skittles left over. All right, wonderful, wonderful. Getting some responses already. Okay, so let's go. I think we've got quite a few responses. That's good. So we can go ahead and solve this together. And so we have 659 Skittles. So let's go ahead and convert that to the nearest 10. 659. And we're looking for the tens place value, which is right here. So this is the tens place value. So we're going to look to the right. And if the number to the right is 5 or more, we're going to increase the number. So this is, because this is 9, this is going to become 660. And then for 439, this is our place value as well. We're going to look to the right, that's a 9, so we're going to increase 3 to 4. So that's going to give you 440. And now we want to find out the number of Skittles left over. So this is a keyword you want to pay attention to. This just means subtract. So we're going to subtract 660 minus 440. And so we're going to subtract this, and you will get 0 minus 0 is 0, 6 minus 4 is 2, 6 minus 4 is 2. So we have 220 Skittles left over. That's the estimate. So it looks like we did well with this question. So let's go to the next question. If there's any question that we're going through, if you're not sure how we did it or you have a question about it, please leave a question in the chat and I'll get to you. So Mentor was given $6 bills. He spent $2.29 on chocolates and $2.95 on fruits. What set of coins should he expect to receive as his change? Some errors here. So what set of coins should he expect to receive as his change? So you have $6 bill here, spent $2.29 on chocolates and $2.95 on fruits. What set of coins should he expect to receive as his change? So we're looking for the change. Let's see, I want you all to give this a try. We want to know what set of coins. So are you all on vacation yet? I know some of you are still in school, but a lot of you on vacation. I know in where we are in Texas, a lot of students are going on vacation this week. Actually, this is their last week of school. I know some states I think have probably another week or two to go. I hope you all are enjoying school. Not on vacation yet? Okay. Yeah, I think a lot of states I think some states, I won't say a lot because I don't know for sure. I know some states in the East Coast are still in session. School is still in session for another 2 weeks. All right, let's go ahead and attempt this question. So we have, I like to always draw a table here and I call it the plus minus. So this is going to be our plus right here, minus. The plus is the money that you have, minus is money you spend. And I don't see a response yet. So let's see. Is everyone having difficulty with this problem? Okay, so let's go ahead and walk through this together. So we have 6 $1 bill, so that's going to give you $6 here. And here you're spending $2.29, $2.29 on chocolate and $2.95 on fruit. So you're going to add up what you spent. 9 plus 5 is 0.76. That is true. That is the total amount you get as change. But what are the different ways you can get 0.76? I'm looking for how many quarters, how many dimes, how many nickels, how many pennies. So there are going to be lots of different answers to this, but I want you to tell me how many, just your thought process around it. So 9 plus 5 is 14. So we're going to write a 4 here and bring a 1 up here. 1 plus 2 is 3. 3 plus 9 is 12. I'm going to write 2 here and then bring a 1 up here. 1 plus 2, 3 plus 2, that is 5. $5.24. So now we have $6 that Mensa has, and he spends $5.24. We want to find out how much he has left over. You said 1.12. I'd like to hear your explanation for 1.12. I'd like to, if you can just type out your thought on how you arrive at 1.12. I'd like to see that. So now we're going to subtract this. 0 minus 4, we can't do that. So we're going to come to the neighbor here. Can't do that. So we're going to come here and we borrow 1 here is 5. The one we borrow here becomes 10. Now we go 0 minus 4, we cannot subtract that. So now we get to 10, subtract 1 from 10, you're left with 9. And the one you subtract becomes 10, and then you add it to 0, so you have 10. 10 minus 4, we have 6. 9 minus 2, we have 7. And then 5 minus 5, we have 0. So it's going to be $0.76 or 76 cents. Okay, so we have 76 cents. That is correct. I think all of you have it right at 76 cents. But let's look at the different ways we can get 76 cents. That's really what the question is asking you for. You have lots of different ways. I can have 3 quarters and 1 penny. That is one possible way, because 3 quarters is 75 cents. 1 penny is 1 cent, so that's going to give you 76 cents. There are lots of different ways, but this is probably the best way to go about it. Anything else would make things a little bit more difficult. So you can have 3 quarters, 1 penny. Let me show you another example. I can have 2 quarters, 2 dimes, 1 nickel, and I can also have 1 penny. So there are different ways to look at it. So but the best set of coins, I guess the smallest number of coins that you will get from a cashier is going to be this. Answer: 3 quarters and 1 penny. All right. Any questions on this? Any questions? If there are no questions, if you have any questions, just post them in the chat. Let's go to the next one, and if you have questions on this topic, I can come back to it. So I had this last week, and I noticed that I had a question like this last week, and I noticed that some of the viewers were not 100% comfortable. So I decided to bring it up again this week and see if we can try to make some sense of this question. So we are going to convert 8 over 11 to a decimal, and then we're going to round to the nearest hundredth. We're going to convert 8 over 11 to a decimal, and we will round to the nearest hundredth. So I'll give you a few moments to try to answer this. When you look at a hundredth, a few things to remember. When you have a decimal, this is going to, you have, let's call this 5, 4, 3. This is going to be your tenth. This is going to be your hundredth. And this is going to be your thousandth. So we want to convert 8 over 11 to a decimal and we're going to round the answer of that to the nearest hundredth. If you're not sure what to do, indicate, and I'll just go ahead and show you exactly how to go about this. Does anyone have an idea what to do here? 5th graders? Any ideas what to do here? Okay, all right, let's do it together. Thank you for responding. So when we have a fraction, your numerator goes, we're going to use long division. Your numerator goes inside the long division and your denominator goes outside the long division. The first thing you're going to do is try to perform a division. So you're going to ask yourself, how many groups of 11 do you have in 8? The answer is going to be 0 because 8 is less than 11. So we're going to write a 0 over here. 0 multiplied by 11, we have 0. And then we subtract and we have 8, sorry. So we have 8. 8 minus 0 is 8. And now we still are where we started. So 8 is still less than 11. So now we can put a decimal here. And then with the decimal, we're allowed to add a 0 to the right hand side of 8, making it 80. So we can actually do some long division. So how many groups of 11 do we have in 80? So if you know your multiplication tables, you know 11 multiplied by 6 is 66, 11 multiplied by 7 is 77, 11 multiplied by 8 is 88. So you can see that we have 80 is between 77 and 88, so we're going to pick 7. So this is going to be, because 77 is less than 80. So we're going to use 7. 7 multiplied by 11, we have 77. And we can subtract here. And we subtract this and we have 3. And 3 divided by 11, we can see that 11 is greater than 3. So because of this decimal here, we can actually add another 0 here. 30 divided by 11, we have 2 groups, so that is 2. 2 multiplied by 11 is 22. We subtract and we have 8. And so we'll do the same. We keep doing this. This is one of those recurring decimals because they never end, but you're going to see a particular sequence. So let's do a few more. So we're going to add a 0 here again. 80 divided by 11, we have 7. 7 multiplied by 11, we have 77. We subtract, we have 3. And then we can add a 0 because of the decimal. And so we have 30 divided by 11, we have 2. 2 multiplied by 11, we have 22. And we're left with a remainder of 8. So can you see that there's a sequence? Every time it's going to repeat the digit 72 or the number 72 every single time. So now we have 0.7272, and I like to do this 3 dots to let you know it continues forever. And now we're looking for rounding this to the nearest hundredth. I hope this makes sense so far. Okay, well, I think we'll do another example of this. We'll do another example of this. So we have 0.7272, and then we want to get to the nearest hundredth. The hundredth position is, if you look at it, is the second digit after the decimal. So this is the digit we're interested in, right here. So we're going to look to the right of this digit. We have a 7. Because we have a 7, which is greater than 5, we're going to add 1 to 2 and make it 3. So this is going to be 0.73, and I can write here nearest hundredth. Okay, let's try another example. So what we're going to do here is we're going to convert, let's see, let's say 4/9 to a decimal, and we're going to convert it to the nearest tenth. Okay, so the first thing you want to do here is you're going to write your 4 inside of your long division and your 9 outside the long division. So we want to divide 4 by 9. 9 is greater than 4, so you cannot have any group of 9 in 4. So you're going to write 0 here. Whenever the number in the divisions, in the long division sign is less than the one outside, you can always start with 0. It's safe to do that. So 0 multiplied by 9, we have 0, and then we're left with 4 when we subtract. Now we're back to 4 over 9, because, so the trick here is, once you get to the point where you have a number here, your remainder is less than your divisor, you can put a decimal point right here. The decimal point allows you to continue to put zeros to the right of the digit when you get to your remainder. So because I have this decimal, I can now add a 0 here. 40 divided by 9, how many groups of 9 in 40? We're going to have 4 of them. 4 multiplied by 9, we have 36. Now we subtract again, we're left with 4. Now because of this decimal, I can make this 40. 40 divided by 9, I have 4 again. 4 multiplied by 9, I have 36. I subtract again, I have 4. Can you see every time I have a remainder of 4? So let's go ahead. So now I have 4. Now I can add a 0 to the end of 4 and make it 40. So 40 divided by 9, we have 4. 4 multiplied by 9, we have 36. We subtract and we're left with 4. Now you can see that we have a repeating pattern. So it continues forever. So this is what we call a recurring decimal, or a repeating decimal. So what you now have is you have 0.444 is going to be 4s until forever. So you're going to now say 4 over 9 is equal to 0.444, and you can put 3 dots to just show that it continues that same way forever. Now we want to get to the nearest tenth. Remember, when you have a decimal, if I have a decimal, I have 0.836. This right here, the first digit after the decimal is your 10th position. And then the second digit after your decimal is your 100th position. And then your third digit is what we call your thousandth. The only difference between this and on the left-hand side of the decimal is that you have the th at the end instead of just 100, 10, and 1000. So now we want to get to the nearest tenth. So to get to the nearest tenth, this is the digit that we care about. So we're going to look to the right. We see that it's 4. It's not up to 5, so we're just going to leave the digit in the 10th position the same way. So now 4 over 9 is equal to 0.4, and we say to the nearest tenth. So the trick with this is try as many examples as you can, try as many examples as possible. The more you do it, the better you become at it. Is a trick I tell every student with math. There's no shortcut to it. Keep working at it and keep trying examples. And if you have any example that you tried and you don't get it, send them to us, and then we'll bring it up here and try to show you how to do it. Okay. All right, so let's go to our 6th graders, I believe. 6th, 7th graders. Express the following in scientific notation. I see that it's got clearer with another example. So what I can do is next week when we have our session, I'll also have another example. The more we do it, the better you become at it, but also on your own, practice a few. So express the following in scientific notation. Let's call this A right here and call this B. All right. So 0.000124, that's the first one, and the second one is 684,000. Where 6th graders, 7th graders, or anyone who knows scientific notation, feel free to respond. After this, I believe we're going to do a puzzle, and then we'll make the mood a bit lighter. So we'll do a puzzle after this, and so everyone who's not in 6th or 7th grade can actually have something to participate in if you're not sure what we're doing here. But I'll try my best to explain it as much as possible. So just remember that everything I'm going to walk you through today, if you go to our YouTube channel, if you have not subscribed, go ahead and subscribe, because every topic that I have here, there's a video that explains it with more examples, because I know with math, it's easier to get better with it when you see it done repeatedly. So we have, all our videos have about 3 or 4 examples on that same topic. So you can see different ways of you can see different examples showing you the method that we use. Okay, so let's go ahead and walk through this together. So when we're looking at scientific notation, we're looking at writing it in this form: a multiplied by 10 to the power of n. N is greater than or equal to 0, and then a is less than 10 but greater than 1. Okay, so now all this simply means is that we're going to come up with our decimal. The easy way to look at this is you want to make sure that your decimal, the number to the left of your decimal, is less than 10 but is also greater than 0. So if I look at this right here, I can see that I have 1, 2, 4. I'm going to put a decimal right here. I'm going to put my decimal here, and that's where the decimal is supposed to be. So 1.24 times 10. Now we want to find out where was the decimal originally. So the decimal was here. So let's see, how many trips do we need to go to get from where we think it should be to where it is, and in what direction are we going. So if I look here, I need to go from here 1, 2, 3, 4. So you see I'm going 4 digits to the left. One thing you want to always remember, when you have a number line, when every time you go into the left, it's negative. Every time you travel to the right is positive. So we're traveling 4 hops to the left, 1, 2, 3, 4. So there are 4 hops to the left, so it's going to be -4. All that means is that I'm moving 4 units to the left, or 4 hops to the left. Does that make sense? So it's 1.24. So Basi, when you're writing your scientific notation, you always want to make sure that the number that is on the left-hand side of the decimal cannot be greater than 10. It cannot even be 10. It has to be less than 10, greater than 1. Okay, the next example, I hope this makes sense to you all. The next example is 684,000. And one thing to remember here is that whenever you when you have a whole number, your decimal is actually right here. Whenever you have a whole number, your decimal is at the end of the number. So you want to make sure, the first step is try to place the decimal where you think it should be, just because of what we said about scientific notation. Place the decimal where you think it should be, and then move ahead, then move that decimal until you get to the place it is in the original question, in the original number you're given, and then you want to count how many hops you're taking and in what direction. If your direction is to the left, it's going to be a negative. N is going to be a negative number. If your direction is to the right, N is going to be a positive number. So here, N just has to be an integer. N is an integer. It can be less than 0. N is an integer, which means it's a positive or negative whole number. All right, so let's go ahead and try to figure this one out. So we have, the best way to do it is make sure that you put a decimal between 2 numbers, and the number to the left is going to be 1 all the way to 9. The number of the right, it can be anything. So now you have your decimal here. You have your decimal here. This is where your decimal should be. Now we need to find out where it was originally, which is what I showed you here. So we're going to move 1, 2, 3, 4, 5. So we have 6.84 multiplied by 10, and we moved 5 units. and we move to the right. 5 units to the right, so that's going to be positive 5. But generally, when you're writing scientific notation, you don't have to put positive 5. So it's going to be 6.84 times 10 to the power of 5. Any questions before we get to our puzzle? Any questions? Okay, let's get to our puzzle. So our puzzle this is similar to what we did last week, but I changed the formula a little bit. So if you remember, so we have an upside down A, 3 upside down A4. Then we have a closed circle 2, a black circle 2. That's going to give you 14. Five upside down A5, and then closed circle 3 or black circle 3, you have 30. 6 upside down 3, 4 is 36. 2 upside down 8, circle 5 is 50. And 5 upside down 6, circle 8, what is that going to give you? Just want you to think a little bit. I'll give you some time and then I'll give you a hint. If no one gets it, I'll give you a hint. All right, let me give you a hint. 3 upside down 4. So look at this. I'm going to 3 plus 4. The assumption is you have 3 plus 4 multiplied by 2. 3 plus 4 with the parenthesis around it, so that it takes, so you have to do that one first. Multiplied by 2 is 14. So then you come here, 5 plus 5 with the parenthesis around it, multiplied by 3 is 30. Does that help? So we have 3 plus 4, parenthesis around it, multiply 14. You got the hint? 3 plus 4, parenthesis around them, those two numbers, multiplied by 2 is going to be 14. And then 6 plus 3, 9, multiplied by 4, 36. 2 plus 8, that's 10, multiplied by 5 is 50. So I think that should give you all the hints you need, and let me know what you come up with. So 5 plus 6 multiplied by 8. 5 plus 6 multiplied by 8. Okay, let's move on. So 5 plus 6, that's going to be 11 multiplied by 8. This is going to give 88. Okay. So just to let you all know, this summer, I know that some of you did not finish your school curriculum. You did not complete it. The teachers were, I think a lot of them were a bit overwhelmed, so they couldn't get through all the topics. So this summer, we're going to offer a summer program starting next week, and it will go all the way till the end of July. Doesn't matter if you're in school. When you're done with school, you can catch up with us. And we're going to have it differently. In our sessions here, we have 2nd through 7th graders. But in these sessions, we're going to have 2nd graders together, 3rd graders together. You wouldn't have 5th and 6th graders in the same class. So 5th graders are together, and we can just focus on things that are relevant to 5th graders. And this is to help you prepare for the next school year. So we will be starting next week. And if you want more details, this is the contact information. If you're interested, let your parents know. I know this will be an exciting time. We're trying to do group sessions, so I know that most of us are going to be indoors, but when you get to see all other students in your grade, I think that makes it a bit more interesting. We get to interact and have a good time. So that's what we're going to be doing this summer. And also know that we have a YouTube channel. Subscribe. Whenever we have new information, we'll post them. When we have announcements, video announcements, we'll post them on YouTube as well, so you can know what's going on at Math East Tutors. And so feel free to reach out to us if you would like to be a part of any of these programs. We have math, science, English, and then for your older siblings, SAT, ACT. And you can also let your parents know or let your siblings know if they're trying to get ready for the SAT or the ACT. We'll have something for them as well. All right. Yeah, you'll be finished on the 19th. Okay. Yeah, I think we can work something out for those that are finishing later, especially if you're in the same grade. We may have a group that is for students that are that are in the same situation with you, or that are finishing school later just like you. So just reach out to us and we'll be able to help you with that. Okay. So we're looking at mixed operations here. 2nd, 3rd graders. Ron buys 3 packs of hot dog buns for a picnic. Each package has 14 buns. After the picnic, there were 15 buns left over. How many hot dog buns were used for the picnic? So we're looking at 2nd, 3rd graders here, and anyone can answer, of course. If you know the answer, or you just want to attempt it, you want to try it, go for it. And we want to find out how many hot dog buns were used for the picnic. How many hot dog buns were used for the picnic? All right, let's try a few more moments and then we'll get okay. Good, Jaden. Thank you for responding. Let's see who else wants to try this. Let me see if I can get 1 or 2 more people, and then we'll go ahead and answer the question together. Okay. Let us answer the question together now. So we have 3 packs of hot dog buns for a picnic, and each package has 14 buns. So let's see, how many buns are there all together? Because this is for 2nd and 3rd graders, I'm going to just at that level, you actually will be looking at multiplication as repeated addition. Okay, Abasi, good work, good work. Thank you for your response. And so we have 3 packs. So we have 3 packs right here. 1, 2, 3. Each of them has 14. For the older students, you can easily multiply, but for the younger ones, you just add these numbers together. So 14 plus 14. 4 plus 4 is 8. 1 plus 1 is 2. Then we add another 14. And so we have 8 plus 4 is 12. We're going to write 2 and bring 1 up here. 1 plus 2 is 3, plus 1 is 4. So we have 42 buns that were 42 buns. Ron had 42 hot dog buns. But after the picnic, there were 15 left over. There were 15 left over. So we want to find out how many were used. So all that simply means is we're subtracting 15 from 42. So 2 minus 5, we cannot do that. So we're going to come over here, borrow 1. We're left with 3. The one that we borrow becomes 10. We add it to 2. It makes this 12. 12 minus 5, we have 7. 3 minus 1, we have 2. So we have 27 hot dog buns were used for the picnic. Simi, good job, good job. So we had 27 hot dog buns used for the picnic. All right. If there are any questions, please feel free to post them, and I'll get back to you on those questions. Now we're looking at customary units. We're going to add the following: 18 feet, 5 feet 3 inches, 1 yard, 11 feet, and 84 inches. We want to add this together, and we're going to express the sum in feet. That's good. Yeah, it's for... What grade are you, man? Abasi? What grade are you? If you're in 5th grade, yeah, it should be easy. What grade? Are there any 2nd graders or 3rd graders here today? Okay, good. All right, so here's a simple thing. Remember what it says here. It says express your answer in feet. So that means everything should have, if you have any of these units, you want to write them as feet. So for example, you have 18 feet. Let's write some conversion here. You have 12 inches. We have 1 foot. 12 inches make 1 foot. Then we have 3 feet would make 1 yard. Okay, so when you have anything that is not in feet, you want to convert it to feet. So this should be fine. This should be fine. We need to convert 1 yard, 11 feet to feet, and we want to convert, actually, let's change this to 2 feet. I think that's what I wanted here. 1 yard, 2 feet. We want to convert that to feet. And we want to convert this to, we also want to convert 84 inches to feet. So 12 inches make 1 foot. We want to convert 84 inches to feet. We have 1 yard here and 2 feet. That's the right one, sorry. 1 yard and 2 feet. We want to convert that to feet. So we have 18 feet. We have 5 feet 3 inches. 1 yard is how many feet? That's going to give, 1 yard is 3 feet. So that's going to be 1 yard, 2 feet will be 3 feet plus 2 feet. That's going to give you 5 feet. So this is going to give you 5 feet. And then 84 inches, you're going to convert that to feet. Remember what I said? If you're going from the smaller to the larger, you always divide. If you're going from the smaller to the larger, you will divide. If you're going from the larger to the smaller, you multiply. So we have 84 inches. So we have 12 inches make 1 foot. So now we have 84 inches. So you're going to divide 84 by 12. And that's going to give you 7 feet. So this is going to be 7 feet. So now you're going to add all this together. We have 18, let's say feet here, inches here, 18 feet, 0 inches, 5 feet, 3 inches, 5 feet, 0 inches, 7 feet, 0 inches. So you're going to add this together. I'm going to put a 0 here, 0. And so you have all this here add up to 3. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 7 is 25. So I'm going to write a 5 here and bring up a 2 here. 2 plus 1 is 3. So this is going to give you 35 feet, 3 inches. Any questions? So let me run through this again. Whenever you have a question like this, look for what is asking you to express your answer in. Look for the unit here. The unit is feet. So anything that is not in feet, you convert it to feet, and then you add everything together. And make sure that you leave your answer in feet. I could have said convert this to yards. That would be a little bit, that would be a bit tricky for you because of the inches here. But I wanted to get you to understand that whenever you're reading a question that has to do with when you're looking at quantities in different units that are related, you want to always make sure that you pay attention to what the answer is asking for. So in this case, we have our quantities in feet and yard and inches, but we want our answer in feet. So you're going to convert everything to feet and then add them together. Don't go ahead and add first before you convert. It would confuse you. So just take note of that. Any questions? Okay. So today I decided instead of just giving you addition and subtraction or multiplication and division, I'm going to give you a word problem that makes you do all of them together. So Uncle Ben visited his nephews and nieces. He gave his nieces 2/3 of the money and his nephews received 1/3 of the money. So I gave you a lot of that already. If the nephews received $50, how much did each of his nieces receive if there are 4 of them? So Uncle Ben visited his nephews. He gave his nieces 2/3 of the money and the nephews got 1/3. The nephews were given $50, which accounts for 1/3 of the money, and his nieces got the rest, which is the 2/3. How much does each of his nieces receive if there are 4 of them? It is a lot easier than it looks. There are lots of different ways to answer this question, actually. I can think of 3 right now that I could probably use. But think about it. The nephews received 1/3 of the money. 1/3 of the money is $50. So what is going to be 2/3 of the money? And you're going to use that too. And then once you get 2/3 of the money, you are going to now figure out what that amounts to. So here's what the nieces have: 2/3 of the money. The nephews get 1/3, and the nephews get $50. So you want to find out how much each of his nieces receive if there are 4 of them. So those are the key points in this question. Anybody have an idea what to do? So one third of the money is going to be actually $50. So you have two choices here. Okay, Simi, good. We have two choices here. We can find out what if 1/3 of the money is $50. What is all of the money? So how do I get to all of the money? I can multiply. If you look at 1/3, let's draw a circle. All right, that's good. Adebumi, that's good. So we have this right here. So this is 1/3, right? So this is this is 1/3. The shaded portion represents 1/3. So one piece out of 3. So how can you get all the whole? The whole is going to be multiplying by 3. If I multiply 1/3 by 3, what do I get? I get a full object or a full circle. So we're going to multiply this by 3 and then multiply this by 3. So all of the money is equal to $100. No, 100, not 1,000. $100 is all of the money. Sorry, 150 is all of the money. So we have 150. So you can now say that Uncle Ben gave his nephews and nieces $150. He gave his nephews $50. How much did he give his nieces? We now subtract 50, and that's going to give us $100 for his nieces. And then we're now told that there are 4 of the nieces. How much does each of his nieces get? You now divide 100 by 4. So 10 divided by 4, we have 2. 2 multiplied by 4, we have 8. We subtract and we're left with 2. Bring down 0. 20 divided by 4 is 5. 5 multiplied by 4 is 20. So remainder is 0. So each niece gets $25. That is correct. That is very correct. Another way you could actually have done this is you have 1/3 is, let me see if we can get some space here. So 1/3 is $50. 2/3 is 1/3 multiplied by 2. So you can multiply 50 by 2, you get 100. So you can see that when you add this up, you get 150. And then with this in mind, you can just divide this by 4, get you to 25. So this is where math becomes relevant, or it becomes real in your everyday life. So that's what I'm going to try to be doing. I'm going to try questions that you can use in everyday life. I'm sure you've probably seen something like this before. All right, so because of time, we're going to go to our final puzzle for the day. We're going to our final puzzle for the day. We're going to find the missing number here. Find the missing number. So good job to everyone who answered the last question. Always remember, it's not about getting it right. It's about, learning the simplest way or the best ways to go about answering this type of questions. So we have, okay, Jaden. Good job. Good job. So we got an answer already. So we got 1, 2, 2, 3. We got 7 in the center. 2, 4, 1, 5. We got 14 in the center. 3, 5, 6, 4. We got, okay, 42. All right. So does anyone need a hint? Let me give you a hint. If you need one, I'll give it to you. Anybody need a hint? So good. So far, so good. So let me give you a hint. Simple hint here is multiply across and add. 18, 21. Those who have 21, I'd like to hear how you got to 21. Let's see if it's a valid answer. So, Abasi, I'm not sure why you changed your answer. What was your reason for changing your answer? Actually, those who got, I see 21, there are quite a few 21 responses. I'd like to know how you got to 21. Maybe there was something I wasn't thinking about when I was coming up with the puzzle. $17 or 18. So we're going to multiply across. Look at it this way. 2 multiplied by 2 is 4. 1 multiplied by 3 is 3. 4 plus 3 is 7. 2 multiplied by 5 is 10. 4 multiplied by 1 is 4. 10 plus 4 is 14. And then you use that here. Okay. So 3 multiplied by 4 is 12. 5 multiplied by 6 is 30. 12 plus 30 is 42. So great job everyone. Great job. Thank you. I see some new faces today. Thank you for joining us today. Really appreciate your visit and your time with us today. I've enjoyed it, and we do this every Tuesday at 1 p.m. Central Standard Time. For those in the East Coast, that is 2 p.m. your time. And on Tuesdays, we focus on second graders all the way through about 7th graders. Sometimes there may be a first grade, but most of the time it's 2nd grade to 7th grade. And on Thursdays, we have 8th graders to 12th graders, including college students as well. And so we're going to try different things during this summer. We may do something different next week. I'm not sure yet. But I thank you for joining and for participating. Those who have been attending all the time, thank you for your support. It's you all that make it rewarding for us to do what we do. Come out here and just walk through math together. So I really enjoy your time. And please let us know if you have any questions. If there are any topics that you're struggling with, let us know. And don't forget that during the summer, starting next week, Monday, we'll be having a summer program where we'll review the topics in your current grade and also prepare you for the next grade. Because of the pandemic or the virus issue, some schools were not able to finish. So we want to make sure that when you go to the next grade, you are not behind. So that's the intention. And we're going to make sure it's focused on your class alone. We're not going to group 4th graders and 5th graders together. We're just going to make sure we can focus on 5th graders for 1 hour and only answer questions that are relevant and are helpful to you. So I look forward to hanging out with you next week. If you have time on Thursday, you can join us on Thursday. We'll be looking at 8th grade stuff. So if you're in 7th grade right now and you're going to 8th grade, come join us on Thursday. We'll be glad to have you, and we'll be working on questions that are relevant. So thank you for your time. Have a blessed day. Enjoy your weekend. And for those of you on vacation, stay safe and stay busy. Don't be idle. All right. Thank you and have a wonderful day.